Okay, so for this lesson and for this unit, really the big thing that we really need to cover and go over is reviewing domain and the concept of domain and range for our rational functions unit. This is kind of a prequel to the next video, so this one should be super short, but here's one thing that I kind of want to talk about when it comes to domain. So the domain is the x coordinates on your graph that exist or do not exist. When we are talking about graphing something, we're talking about wanting to make sure that the values that we graph can be plugged into the equation given and that they will work in that equation and that we can utilize them for graphing the actual function itself. So there are some restrictions that you need to know and be able to note for domain. Most of the time when we talk about domain, we actually talk about it being in interval notation. You'll see that a lot. And so we're going to go over two different types of notation, one where the restrictions are listed and one where it is interval notation. Okay, so let's talk about restrictions. Domain restrictions. There are three we talk about, or four different types of domains, okay? The first, that's not four, the first one being a polynomial. Now, a polynomial is a function where you can just kind of plug anything into it. There are absolutely no restrictions for polynomials. Anything can be plugged in. I can plug in 100, I can plug in 1,000, I can plug in 3, 4, 5, it doesn't matter. Anything will work. So we actually call that all real numbers. All real numbers work here. And our notation and how we write it would be by saying that from negative infinity, in parentheses, to positive infinity, I can choose values in between that range. So starting with negative infinity for x, all the way to positive infinity for x. Because remember, the domain is the x coordinates, so you're looking for x coordinates that work, not y coordinates. If the x coordinates work, then you should find you a y coordinate because that's what a function does. Now, when we are talking about restrictions, there are three other types of restrictions that you need to focus on. The first one being the absolute, not the absolute value, the square root of x. Underneath a radical, and we know this from our radical unit, but underneath a radical, x cannot be greater or cannot be negative, so it has to be greater than or equal to 0, because you can't have a negative under a radical. That where x is greater than or equal to 0 should exist for this specific function. Now this is the most basic function, so anything added or subtracted to x, you'd have to make adjustments here. But one way to kind of write this is to strictly state that x has to be greater than or equal to 0. This is telling you all the x values that exist. Another way to write it, it would be to put it on a number line. 0 is in the middle. And to put a closed circle above 0, representing that that exists. And that is a part of my graph. And then drawing everything an arrow to the right, saying that anything greater than or equal to 0 exists. This is one way to graph this inequality right here. Okay? Now, to write it in interval notation, it's just like using this inequality, but we look at the graph and we say, okay, from left to right is how I'm going to write my interval notation. So just like we used to put a closed circle up here to show that that point was also a solution, we are going to utilize a bracket to show that 0 is a solution. Now you go from left to right like you read a book, and we start with 0, and then we go to infinity. So everything from 0 to infinity works. So this is the interval notation for x is greater than or equal to 0. That's how you would show that it exists on a graph. Now here's the thing, a couple of things. Closed circle is the same thing as brackets. Closed circle is the same thing as brackets for our interval notation, which means that it is included, that it is equal to. An open circle on our number line we would utilize parentheses instead of brackets. And that means that the value is not included, so it's not equal to. So it would have to be everything that is greater than or everything that is less than that value, but not including that value. So those are notations that you need to know, and this is how we utilize interval notation, is by using the brackets or the parentheses. Like from the number line, we would use the open circle or the closed circle. Okay, so that's one of them. The next one is 1 over x. 1 in the denominator of any fraction, you cannot have 0. This is the most important one, okay? And this is our rational case. This is what this unit is all about, all right? So this is our rational case, is the third one. But this is stating that x cannot equal 0 because I can't divide by 0 in a fraction. So how would I write that on a number line? Well, everything but 0 would work. So we would go to 0, and we would put an open circle above it, and then we would draw everything to the right would work, and everything to the left would work. So everything to the left approaches negative infinity, and everything to the right approaches positive infinity. Now, to write this in interval notation, you would state starting from negative infinity, stopping at our first interval, so this is an interval, so stopping at our first point, from here to here is an interval. So I would stop at 0, put parentheses, a union, parentheses, 0 to infinity. And then that would be my interval notation. Okay, so that's for your rational case when you have x in the denominator of a function. So when you have x in the denominator, that's when you can't have 0. The next one would be combining the two, where I have 1 over the square root of x. If I have 1 over the square root of x, that is where x has to be greater than 0 because it's a square root, but it's also cannot be equal to 0 because it is in the denominator. So if you have an x in the denominator, it cannot equal 0, and because it's under the square root, it cannot be negative. So this is x has to be greater than 0. So starting at 0, we would put an open circle above, and we would shade everything to the right, showing that it is greater than, approaching infinity. Now this one would start from 0, and would stop at infinity. And we would use parentheses to show that it's not included. So these are the 4 types of domains and things that you're going to see a lot of. We're not going to talk a lot about the second and fourth one this unit. Really going to stick with that rational function one. But I want to go over really quickly kind of just finding the domain of an example, maybe 2 examples. I'm going to put 2 examples on the board. I'm going to pause real quick so that I can get the examples written up, and then you'll see them in a second. Okay, 2 examples on the board. Go ahead and pause and write these down. We are going to go over finding the domain for these 2 examples. So in the first one, I have x plus 2 over x minus 3. Now, this is a rational function because x is in the denominator of the function. That's what makes it rational. It's a fraction. So in this case, we're following the third step here, the third case, where x cannot equal 0. And more specifically, it's not that x can't equal 0, it's that your denominator cannot equal 0. So if your denominator equals 0, that's where you have an undefined function. So I'm not worried about the numerator here. To find the domain, I'm only worried about the denominator, x minus 3. X minus 3 cannot equal 0. Sorry, my computer's being a little slow. So x minus 3 cannot equal 0. So how do I find what x cannot equal? Well, I would set it equal, not equal to 0, and solve. Add 3 to both sides. X cannot equal 3, because that's where 3 would make the denominator 0. That is it. That is finding the domain. This is one way to find the domain, is by stating the restrictions. Another way to state domain is to put it in interval notation. Now the interval notation, I always started on a number line, and then I would say, okay, well 3 is the value that does not exist, that gets the open circle above. Everything to the left and right are fine. So where does it start? Sorry about that. Where does it start? Negative infinity. Where does it end? Positive infinity. So now I'm going to go from negative infinity to 3. I'm going to put a union. This union sign means or. I don't know if we talked about that before, but this union sign means or. So my answer could be either here or it could be in this other group, which starts at 3 and goes to positive infinity. So you're showing each interval in parentheses, and this is how it's read. Okay, and that's my easiest way to kind of explain it, but both are considered the domain and both are kind of considered the answer. Now, which one do I want you to practice? I'll be honest, you need to know how to do interval notation. Okay, it's very, very important. Anybody can say that x can't equal this, x can't equal that, but you need to know how to do the interval notation. So please practice that, at least for most of your problems. And then if the interval notation gets really, really long, then you can revert back to just stating the restrictions. But make sure that you're using interval notation just so at least you get the practice in. Looking at this second example, I have factored form in the denominator here. I actually have two things. Here, if this x minus 2 was equal to 0, then the whole thing would be 0. So I actually have two things that I have to set not equal to 0. I have x minus 2 and x plus 5. Now notice we're not even worried about the numerator because 0 is okay in the numerator. It is not okay in the denominator. So we're going to solve for this, and I get x cannot equal 2 and x cannot equal negative 5. Now those are acceptable ways to write not interval notation, but those are acceptable ways to write your restrictions. To write interval notation for something like this, it looks a little different. So we're going to start at negative 5, put an open circle above it, then go to 2 on my number line, put an open circle above it. Everything in between, all the space in between and the space onto the left and to the right are okay. Anything in between negative 5 and 2 works. It's the only exceptions I have are negative 5 and 2. So how does this get written in interval notation? We're going to start with our lowest value. Our lowest is always going to be negative infinity. And then we're going to stop at our first value here, negative 5. That's the first interval, negative infinity to negative 5. Then I'm going to show the next interval by separating it with or, which is that union, and I open parentheses, negative 5 to 2. Then I'm going to start the next one, open parentheses, 2 to positive infinity. So there is my interval notation. Now I have 3 different intervals. Just like on my graph, I have 3 different intervals. I have 3 different places. So that is how you write it in interval notation, or you could write it as restrictions. But please make sure you know how to do the interval notation for future problems. Okay, hope this helped.